Hey folks, it's time for some science. Well, it looks like we made it through our first week back in physical science, and this is also the first week when we're focusing on physics. So I thought this would be a good time to go back through the things that we've learned and just sort of review what we've seen so far. Without further ado, I'll jump into that. So the first thing that we learned on Tuesday was what a position graph is and how to make one. So a position graph basically tells you how an object moved over time. They're pretty easy to make. All you have to do is take the position of an object and plot that on the y-axis, where the time that it was at that position is on the x-axis. As you make these little dots, you can connect them, and it gives you an idea of what path the object took. Now, when I say that, understand that these things only tell you if something is moving forward or backwards, that is, like, away from the origin or back towards where it came from. And so that brings me to my next topic that we covered. On Wednesday, we covered the three big things that you can learn by reading a position graph, notably the position at a given time, the direction that an object went in, and how fast it was going. For position, it's as easy as saying, oh, I want to know how fast something was going at maybe 12 seconds. Well, I come over to 12 on the x-axis, and I follow it up and see where that meets on the y-axis. That tells me its position. It's that simple. When it comes to direction, remember that these graphs only tell you if something's moving forward or back, and it's sort of up to us to decide what that means. We usually say it's away from the origin is positive, towards it is negative. And so, if the graph is going, let me come over here. If the graph is going up, that's forward. If it's moving down, that's backward. And if it's not moving, it'll just be a flat line because it's staying at that same position over time. And then we have speed. Basically, we said that the steeper the graph is, so the higher the slope, if you want to use math terms, the faster it's going. So if you've got something like this or this, that is a fast object relative to this or this. These are slow objects because they're not as steep as these guys, and so they're not moving as fast. Now, the cool thing is this guy is moving fast backwards. This guy is moving slowly forwards. Think about that for a minute. And then finally, we learned how to take these graphs and tell a story with them, or basically figure out how the object moved in total based on the graph. So take this one for instance. If I told you that this was the path my dog takes to the grocery store, well, you know that he starts out moving really fast because he's got a steep slope, and then he stops right there. You know that because it's flat. He stays in the same position as time goes on. Then he turns around, we know, because he goes backwards. He goes down in slope. And then, since it turns up again, we know that he starts moving forwards again. Both of these are at a much more moderate pace. And so you can see how we can use these graphs to kind of figure out the behavior of an object, or again, a dog, a person, anything really. So I hope that that was fairly concise and that you guys are ready to now take your quiz. That's all I have for you today, folks. Have a wonderful weekend.